Okay, in this problem here, basically what we have to do is to plot this function and then calculate the inflection point and calculate the tangents to these inflection points and draw them along with the function itself, right? Okay, let's try to plot the function. Well, first of all, the domain of the function is R, and it's continuous and differentiable there, no problem about that, because the argument of the logarithm is always positive, right? It is also an even function because it depends on f squared alone, on x squared alone, right? So we just need to see what happens on the positive side, and then the negative side we have a mirror image of this. Okay, let's calculate then the derivative. The derivative of that function is equal to 2x over 1 plus x squared, which on the positive side is positive. Okay, so this is positive. If x is positive, is negative. If x is negative, so at 0 it's got a minimum, right? So it's increasing here, decreasing here. So x equal to 0 is the point of the minimum, local minimum, where the function, by the way, is equal to 0. Yeah, equal to 0 because x squared is 0, then this is 1, logarithm of 1 is 0. Okay, right. But we need the inflection points, so we have to calculate the second derivative of this function. So that is 2 times 1 plus x squared minus 2x squared divided by 1 plus x squared squared. Okay, and this is equal to 2 that multiplies 1 plus x squared, and then this is 4x squared, therefore minus 2x squared, right? Divided by 1 minus x plus x squared squared. So this difference is 1 minus x squared. So this is it, right? Well, it's clear from this function is positive when the absolute value of x is larger than 1, and however is negative when the absolute value is no, the other way around, when this is smaller than 1, okay, and it's positive when this is larger than 1, right? So the function is convex between minus 1 and 1, and it's concave otherwise, right? And it's got inflection points at x equal to plus minus 1. These are inflection points. How much is the derivative of those points? Well, if you substitute here, this is 1, right? 1 plus 1 is 2, 2 by 2 is 1, so you have plus and minus 1. Okay, so, and how much is the function f at the point plus and minus 1? Well, the function at those points is the logarithm of 2. So if you want the plot of the function or the tangents are logarithm of 2 plus or minus 1 times x minus and plus 1. All right? Okay, these are the two tangents. Right, so we can now plot everything. All right? There's no horizontal asymptote because the logarithm of 1 plus x squared diverges to infinity, right? So if we plot this, okay, this is what the function and the tangents look like, right? There you go. So you got the function, which is, well, is symmetric, of course, respect to this, is increasing all the time here, therefore decreasing here. The derivative is, well, the function is increasing, as I said, increasing the positive side and decreasing the negative side, therefore this is a minimum. At the minimum the function is equal to 0, and then it is a convex from 0 to 1, well, convex from minus 1 to 1, and concave otherwise. and it grows to infinity, and actually it grows. Logarithm of 1 plus x squared is equivalent to, well, it's actually, yeah, equivalent to, let me put it right. This is the logarithm, okay, is equivalent to 2 times the logarithm of x, or the absolute value of x, because when x is very large, this is when x goes to plus or minus infinity, right? Because when x is very large, then the 1 is irrelevant, it's negligible, and then you have logarithm of x squared, which is twice the logarithm of the absolute value of x. So the behavior of the asymptotic branches here is like twice the logarithm of x. Okay, right, so there you go, and here you can see the 2 tangents. These are the equations of the tangent. Right, this point here is the logarithm of 2, okay, which is the same point there and there. And then at this point, which is 1 and minus 1, at these 2 points, the slope of the straight line is 1, right, or negative 1, okay. And you can see from the fact that the function is above the tangent and below the tangent on the 2 sides of this point, that these 2 points are inflection points. So this is the plot of the problem.